Hello all, Dr. Mayaduna here. Today I am bringing you the atomic number and the periodic table. Periodic table is very useful for us. If you see, like we have like hundreds and hundreds of elements. All the elements we can see around us are listed in this periodic table. the For me, I feel the learning of the periodic table is very important because I learn about all the nature and everything surround us. And also we're also going to talk about the atomic number, and I'll show you in this video how this atomic number and the periodic table is very relatable. So first, let's look at what are the learning outcomes of this section. So you can see this is the picture of the diagram of periodic table. You can see all the elements. So in periodic table, usually we list, all the elements you can find on Earth, or if you find something in space. Okay, think about astronaut bring another new chemical, like new element, we always list in the periodic table. So if we go to the next slide. So these are the learning objectives. In other words, when you finish this section, you should know what is the atomic number and what is the mass number. You need to know what are the isotopes and to identify the isotopes. Oh, the next thing, we are moving to the periodic table. Identify the periodic table, and you need to understand the periodic table. And then we have some classifications. Example, we classify periodic table into metals, non-metals. You need to know that. And all the elements in the periodic table, please familiar with those elements. As a chemistry students, you need to know the chemical symbols, like what is the chemical symbol for oxygen? It is O. What is the chemical symbol for gold? It is AU. Like that, you need to familiar, okay, this is the chemical symbol. So chemical symbol is the universal way you recognize that element. So that is very important. You identify the chemicals, these elements, by the symbols. So let's move on to our very first section, which is the atomic number. The atomic number it's very important. It is the symbol for atomic number is Z. Then atomic number is number of protons in the nucleus. Number of protons in the nucleus is unique for each and every element. Not two elements share the same atomic number. In other words, atomic number defines the element. Example, nitrogen atomic number is 7. Any nitrogen atom, you have 7 protons in the nucleus. So atomic number is very important. That is the unique, that is the one best way to identify, okay, that is nitrogen. If I said, okay, I have element with 7 protons, what is that element? It is definitely nitrogen. I have element with 6 protons. 6 protons is oxygen. The number of protons define element, that is the atomic number. Atomic number is the unique way to identify an element. And then we are moving to the mass number. So think about the atom. You can visualize the atom, or else I can draw you the atom. Let me go here. So if you take atom, let me draw this one for you. So if you think about the nitrogen, so the atom, so you see you have the nucleus here, and then the nucleus you have protons and neutrons, and then around the nucleus you have the orbitals you have electrons, right? So this first orbital, you have 2 electrons, and then this is the nucleus. Let me take another color. Okay, it's okay there. Let me see. Okay, so you have the protons and the neutrons, right? So if you think about this element, so you have the protons and the neutrons in the nucleus, and then the other electrons surrounds the nucleus. So atomic number is number of protons in an element, and then the mass number is total number of protons and neutrons both, because nucleus you have two subatomic particles. Two subatomic particles in the nucleus are protons and neutrons. The protons and neutrons in a nucleus we call mass number. So far we learned two things, which is atomic number, number of protons in an element that is unique and define an element. Then we learn about mass number. Mass number is number of protons and electrons in an element. And if you see, there is a unique way you write the chemical symbol, the representation of element. If you see here, and I want to look at focus here now, you see this element symbol, it can be Z is the symbol. And then this is a way of representing. You write Z, the below is, this is the atomic number, number of protons, and on the top, the mass number, which is number of protons and neutrons. If I write an example for nitrogen, let me take nitrogen chemical symbol N, and then number of protons always 7, and then number of protons and neutrons in the nitrogen nucleus, you have 7 protons, 7 neutrons, so you write 14, N7 14. This is the way you represent an element. So I go to the next section. Okay. Go there. Okay, I go to the next section, and then you see here I have the examples of the hydrogen, which is the very first element in the periodic table. Proton 1 to 1, 1 2. What are these? This is the same hydrogen I have listed here, but you can see I have listed 3 different hydrogen atoms. Why I listed 3 different hydrogen atoms here? In first one, you see 1 proton, but in the nucleus you don't have any neutrons. Second one, I have 1 proton, but 1 neutron. Third one, I have 1 proton, 1 neutron. All these 3 are hydrogen atoms. What's the difference? How do I know all these are same hydrogen atoms? What I'm looking at, this is 1 proton, 1 proton, 1 proton. All 3. I told you at the beginning, number of protons, atomic number defines an element. It's unique. So number of protons, 1, it's always hydrogen. So you see always 1 proton, it's hydrogen, but you see the number of neutrons different. The number of neutrons different in hydrogen makes its different mass number. So now I'm coming to the isotope. Isotope is the elements have same number of protons but different number of neutrons. So here in these 3 isotopes they have same number of protons, which is 1, but the number of protons different. So that makes it isotope. All the elements, most of the elements in the periodic table, they have isotopes. Isotopes means they have same number of protons, but the number of neutrons in the nucleus is little different. But we listed only one most abundant. In nature, if you take 100 grams of hydrogen, you have all these 3 isotopes. But in the periodic table, we listed mostly the most common isotope. So we learn about isotopes. And I'm going to the next section. Can escape it. I go to the cancel. Okay, here. Cancel. Yes. Okay, sorry. So I go to my next section, which is, okay, so I have some examples. My examples are determine the number of protons, neutrons, and electrons in each of the following species. So let's look at this question. So I have the very first one, which is chlorine. Let's look at chlorine. So in the chlorine, let me go here. Okay, in the chlorine, I have chlorine 17 Let me write it here. I don't need that. Okay, I go there. Okay, so I take this one. So chlorine 1735. Chlorine 1735. Determine the number of protons, neutrons, and electrons. So number of protons is, so atomic number, which is 17. Number of neutrons is this one. 35 is the both. It's the sum of both neutrons. So this is a mass number. Mass number is both the addition of neutrons and protons. So how many? So you know protons 17, and then the neutrons 35 minus 17, which is 18, right? It's 18. So the neutrons is 18, and then there's electrons. This is neutral. Neutral means no charge. When there's a no charge, number of protons always equal to the number of electrons. So here in the first chlorine, first question, we figured it out. Okay, we have number of protons 17, because we know it's 17 because it's here, atomic number. And then the top one is the mass number. Mass number will give number of protons and number of neutrons. So you know the number of protons always 17, and then you subtract 17 from 35, you get number of protons. And then I look back, now I have to find the electrons. I can just get back electrons. Electrons in this species, number of electrons and protons are same because it is neutral. When the element is neutral, the number of protons and electrons are always same because electrons negatively charged, protons positively charged. No charge, neutral means number of positive and negative charges are balanced out. So we learned the A. Then I'm moving to B. I just have one information. CL 37. So how do I know number of protons? Open the periodic table. Periodic table, you see at the very bottom, it's look at the box of chlorine. Go to the periodic table, and then if you look at the chlorine box, you see in the periodic table, in the exam also you get the periodic table as a supplementary material, and then you can see in the box of chlorine 17. Always chlorine has atomic number 17. It's listed in the periodic table. So you know, okay, number of protons is 17, atomic number is 17. So you know number of protons 17. Even though it's not given, you know number of protons, atomic number is 17 because it's given in the periodic table. And then neutrons, U37 minus 17, you get 20, right? 20 neutrons. The element is neutral, number of protons equal to number of electrons, 17. So we did 2 practice problems, and then this practice, so we learn atomic number and the mass number and the isotopes. So you can, from that knowledge, you can answer these questions. The remaining problems, C and D, you can see I have given the question answers in the PowerPoint, but I want you to do by yourself first and then look at the answer, and then you can compare the answers. If you have any question, please feel free to email. I'm here to help. So always, if you have a question, you can email me. I can explain it to you again, or I can make another video for you. Okay, now that's the end of the very first section. With the very first section, we discuss atomic number, mass number, and then isotopes. Now we are moving to our next section, which is part 2 of this video, which is periodic table. Periodic table is important. It has listed all the elements you can find in the nature. The periodic table, the very first scientist who work on there are so many scientists in the ancient time work on the periodic table, but Mendeleev is the one scientist who work a lot, who generate the periodic table at the very beginning in 1860. He noticed that when the elements put it in the straight line, he saw, okay, the elements with similar properties recur periodically. And then he collect these elements with the similar properties and he put it in the groups. At that time, certain elements haven't even discovered. So if he cannot fit to an element to a certain group, he left it a blank. And then he found, okay, these are the elements have similar properties. Okay, like that, he made them into groups. And then the elements he couldn't identify and couldn't discover at that time, he predicted those properties. I mean, even though without an element, example at that time, silicon wasn't discovered in the Mendeleev time. But Mendeleev leave this space blank, but he predicted, okay, it can be a solid. Its melting point is can be this much, because using the properties of the group, he predicted the properties. So like that, but right now we have the periodic table. We have like, I listed 103, but right now we have like around 106 elements every day. The elements are like, the scientists doing so many experiments and the research, and they add elements to the periodic table. So this is the periodic table, and we have the classification. If you see the color code, like a bluish, like a green color or like gray color, you see these, the shade elements, they are all metals. The blue color elements, all non-metals. The orange color are metalloids. So very first classification, main classification, we can classify periodic table into metals, non-metals, and metalloids. What are these metalloids? Metalloids are the elements which show properties in between metals and non-metals. And also the periodic table, if you see these vertical lines, we call them groups or families. Why? This group, like lithium, sodium, potassium, rubidium, cesium, francium, it's a one group. Why we call it a one group? Because elements in that group share some similar properties. So we call that as a group. And then if you think about the horizontal lines, we call them as periods. Periods means they have like always, they have like, okay, this is a first period. This is like for hydrogen and helium is in the first period. Lithium, beryllium, boron, carbon, nitrogen, this is the second period. It goes like that. So this is the very first classification: metals, non-metals, metalloids. So in the exam, if somebody asks, okay, chromium, identify it's a metal, non-metal, or metalloid, you need to know, you need to look at the position in the periodic table, which is in the metal area, so it's a metal. But if it is if you think about sulfur, it is a non-metal. If you think about antimony, which is Sb, it is the um, metalloid. So, and also it is important when you learn the periodic table, you also familiar with these element symbols. So the element symbols, they derive from the, like, the name of the scientist who discovered them, the country which the element found at the beginning. So like that. So example, like the hydrogen H, helium He, and then there are some names like magnesium Mg, sodium. We call sodium, but the symbol is Na. Why sodium is not SONA? Sodium, the Greek name for sodium is natrium. In order to honor the Greek name, we call sodium Na. So in the exam, if you see Na, it is sodium. I'm not always right sodium. Always the chemist, as a chemist, now you're a chemist. Chemists always use chemical symbols. So practice. Look at it. Try to familiar with these chemical symbols. I'll show you an easy way to do it. Maybe you can just get the blank periodic table without the names and try to write, okay, H is hydrogen, this lithium. Like try to do like little flashcards. You can use Quizlet. In the if you think about in the class, you can see the Quizlet worksheets, Quizlet activities with the periodic table. So try to be familiar with the periodic table. Another good thing is you can take the periodic table, you can post it in front of your study table, so you see it very often. In that way, you can familiar with these, the symbols. It's very important you're familiar with the chemistry symbols, because when you get out from the class, if somebody asks, like you say, okay, Na, you need to know that is sodium. Au, it is gold. Like, and when you work in the industry, they don't say, okay, they don't write in the like a names, they write chemical symbols. And also in the exam, it's going to be so much easier, and you'll be very confident if you know these elements by names. Okay, so then we talk about the vertical columns, the groups and the periods, and then when we talk about groups or families, and then there are certain names for each groups or families. Look at this group, the very first group, which includes lithium, sodium, potassium, which is symbol K, rubidium, cesium, francium. We call this group alkali metals. In the exam, I ask, identify alkali metals. You need to know what are these alkali metals. It's important you understand the concept. And if you know, okay, alkali metals are group 1 in the periodic table, okay, the group 1 alkali metals. So it's not that hard. And then you go to alkaline earth metals, group 2 goes to the alkaline earth metals. And then you go to the group 6, chalcogens. You see this is group 6. You may wonder why this is group 6, because you see the numbers, right? These are main group elements. This is called transients. And always we give like group 1, 2, 3, 4 for the main group elements. So this is, if you think, 1, 2, 3, 4, 5, 6. So it's group 6, chalcogens. Group 7, halogens. Group 8, noble gases. You see each group, okay, these are the elements in the noble gases, and then see the helium, neon, argon, krypton, xenon, radon. So these are the groups in the periodic table. And then you see the middle group, we call them as transition elements or transition metals. And then before summarize, I like to show you something interesting in this periodic table. You see, if you look at the periodic table, I told you we list all the elements we can find on Earth, and you see most elements that we see around us are metals and few non-metals. I thought, okay, there are a lot of non-metals around us. No, that's not true. There's a lot of metals around us. I mean, variety. If you think about variety, it's a lot of metals on the earth core, and metals are more now, like if you think about more variety of metals around us, less than if you think about non-metals, very limited, like very few non-metals. And then some metalloids also. Metalloids you can find in the more like electronic, like the computer chips you can find, and then the semiconductors. So these are the non-metalloids. So the metalloids, they show metal properties and also the non-metal properties. So I hope you understand the periodic table. To finish this lecture, I like to summarize what we did so far. We talk about at the very beginning. This lecture has two parts. First part, we talk about the atomic number. So we talk about in the atomic number, we say, okay, what is the atomic number? Atomic number is number of protons, right? We talk about atomic number, which is Z, number of protons in an element, and then we talk about the mass number, which is M, and then the mass number is number of protons and the neutrons in an element. And then we also discuss, if you have like element like chlorine 1735, then the 17 is number of protons, 70 is number of protons, and then 35 is number of protons plus neutrons. If you see this way, you can find, okay, number of protons here, and then you go to here, and then it gives you the protons, and then 35 minus 17 give you 18, which is number of neutrons, right? And then electrons, always if it is a neutral element, number of protons and electrons are same. And then we also discuss about the periodic table. Periodic table lists all the elements we can find on Earth, and then the classification. We first classify into the metals, non-metals, and metalloids. And then we talk about the groups, how it classifies into groups. Group 1, alkali metals. Group 2, alkaline earth metals. And then the group 6, chalcogens, halogens, noble gases. And I hope this video helpful for you to understand atomic number and the periodic, familiar with the periodic table. And then there's a homework. Please complete the homework associated with this chapter. And then again, if you have any question, I'm here to help. Please feel free to email me. Thank you and have a blessed day.